Good morning, dear students. Hope you are doing good. As we are in 5th unit, today we are going to discuss the continuous part of the topic what we have started in the previous class. In the previous class, we have seen the theories of disinfection. We have seen various theories of disinfectants. Today, as part of our session, we will discuss the topic in the name of chlorination. I told you in the previous class itself, the other best disinfectant is chlorine. Other in the sense, as we already started the topic, theories of disinfectants, where we have seen the different types of disinfectant methods: boiling of water, ozone, ultraviolet rays, iodine and bromine, potassium permanganate, excess lime, followed by chlorination. Followed in the sense, this is also one of the best disinfectant method to be used to kill the bacteria. See here, theories of disinfection. The substances which are used to kill the bacteria are called as disinfectants, and the procedure which is used to kill the bacteria called as disinfectant methods. Else, the process of killing bacteria known as disinfection of water. We have seen boiling of water. Here is a drawback. We may not apply this for large scale of water. And one more drawback is here. We can kill the bacteria, present existed bacteria, but we may not sure, or we are not sure for the future possible contamination of water. Whereas in the ozone, we have seen it is cost effective because it works with electricity and it will be used adaptable when in the areas wherever the electricity is available with minimum cost. Ultraviolet rays, we can adopt this method for the water whose turbidity is less. If the turbidity is more, we cannot apply this method because the bacteria will hide under any obstacle and we can't kill the bacteria. Iodine and bromine, we can use this mostly, we can adapt this method for industrial purpose. Potassium permanganate, we can use, and it is treated as best disinfectant, especially can be used to kill the bacteria as well as organic matter nearby dug wells, or else for the water which we have been collecting from dug wells. The other one is excess lime. Excess lime also can be considered as one of the best disinfectant. But here, if the lime is keep on adding, or else if the lime concentration is increasing, the particular water may not fit for consumption. That means for every method there are certain limitations. The next one is chlorine or else chlorination. The process of applying chlorine has been divided into different categories. We will discuss one after one. First one is superchlorination. What is this superchlorination? See here, they clearly mentioning, see, extra amount of chlorine than the normal days, especially during the pandemic to control the spread of waterborne diseases. See, that means the process of adding extra chlorine than the normal concentration. More particularly, we can add, or we used to add extra amount of chlorine during the festival times and during the epidemics to control the spread of waterborne diseases. This is what about superchlorination. Double chlorination. Next one is double chlorination. See, chlorination in the sense we are applying chlorine to kill the bacteria. The process of applying chlorine to kill the bacteria is called as chlorination. And it can be adaptable, and it has been practicing with different methods by different names. The superchlorination in the sense we are adding extra amount of chlorine than the normal amount, and more particularly we can add more amount of chlorine, especially during pandemic seasons, epidemics, to control the spreading of waterborne diseases. Double chlorination in the sense we are just doubling the amount of chlorine, and it is mostly used to treat highly contaminated water, which is supposed to be, before supplying to the public. That means by the name itself revealing to us double chlorination, adding double than the required amount, adding one more amount, so double amount of the chlorine, and it is mostly applicable, and it mostly we used to adopt this when the contamination, when the severity of water is more, when the severity of contamination is high. Next one is plain chlorination. See here, the source of water is when the source of water is springs, or else when the source of water are springs, lakes, mountains, or else mountain hills, possibly we will adopt this method where the required quantity of chlorine will be sprinkled at the source points of the springs and lakes, which is called as plain chlorination. What is plain chlorination? The amount of chlorine that is sprinkling at the sources of springs, lakes, mountains, that is called as plain chlorination. Next one is dechlorination. When the wastewater is treating, sometimes there will be need of removing chlorine from the water. To remove the chlorine from water, there are different methods. Among them, the most practicing one is addition of sulfur dioxide, and the whole mechanism is given in the equation. Sulfur dioxide plus CCl2 plus 2H2O, where the chlorine is removing in the name of HCl. Dechlorination. Sometimes when the wastewater is treating, there is a need of removing chlorine. In such cases, by adding sulfur dioxide, we can remove the chlorine. That is the name. As we are removing chlorine, we just named it as dechlorination. Next one is pre-chlorination. There is a need of adding chlorine before the initiation of treating water, which is called as pre-chlorination. Before starting of treatment, the chlorine will be added sometimes. That is called as pre-chlorination. Preferably 0.102, 0.50, 50 ppm before the raw water enters the sedimentation tank. The process of applying chlorine before the initiation of treatment is called as pre-chlorination. Preferably 0.10 to 0.50 ppm will be added before the water is entering into the sedimentation tanks. Next one is post-chlorination. Addition of chlorine after the treatment of water just before to public supply is called as post-chlorination. Before use of water, the minimum contact time should be 30 minutes, and it is suitable for all clean water wells from where water will be supplied to domestic users. Post-chlorination in the sense addition of chlorine after the treatment of water just before supply to the public, the chlorine will be added. Normally, the minimum contact time should be 30 minutes, and it is suitable for clear water wells from where water will be supplied. This is called as post-chlorination. Let us have one more time look about this chlorination. Superchlorination, process of killing bacteria, is called as chlorination. Amount of adding additional amount of chlorine is called as superchlorination. Most probably this is used to control spreading of waterborne diseases during epidemics. Next one is double chlorination. In the water, when the water is highly contaminated, the double the amount of chlorine than the required will be added to control the contamination when the water is being supplied to public domain. As for public usage, plain chlorination, sprinkling of chlorine at the sources of at the water sources like springs, lakes, and mountain hills to control the possibility of contamination is called as plain chlorination. Dechlorination, in the sense, sometimes there will be a need to remove the chlorine during the treatment. In such cases, we'll add the sulfur dioxide to the water so that chlorine will come out, and the whole mechanism has given in the equation itself. This is the equation. And next one is pre-chlorination. The name itself revealing to us pre-chlorination. Before starting of treatment, some amount of chlorine will be added right from the initiation of the process. Right at the beginning of the treatment. That is called as pre-chlorination. Preferably 0.102, 0.50 ppm of chlorine will be added to the raw water before it enters into the treatment works. Post-chlorination, in the sense, after complete treatment, the chlorine will be added after treatment. Before supply of water to the public, chlorine will be added. That is called as post-chlorination. Normally, the minimum contact time should be should be for 30 minutes. For clear water wells, it is suitable from where the water will be supplied for domestic usages. See, whenever you have a question, write different theories of disinfection. You must write all, including with chlorine. Boiling of water, ozone, ultraviolet rays, iodine and bromine, potassium permanganate, excess lime, superchlorination, double chlorination, plain. If sometimes you may get a question, write a detailed notes on chlorination. In such times, you must write superchlorination, double chlorination, plain chlorination, dechlorination, pre-chlorination, post-chlorination, based on the time and based on the marks and based on the way the question comes as a question. Based on the type of question they ask, your answer must be accordingly. Sometimes you see, to the continuation part, the other part which is associated with chlorination is chlorine demand. See, why? What is in demand here? Chlorine is demand. Why? See here, why the chlorine is demand? Sometimes it can be defined as the difference between the quantity of chlorine that is added to kill the bacteria and the amount of chlorine that is stored at the bottom as a free residual chlorine. It is defined as difference between what? The quantity of chlorine that is added to kill the bacteria and the amount of chlorine that is used or is that is stored at the bottom as free residual chlorine. Understand? It can be defined as the difference between the quantity of chlorine that is added to kill the bacteria and the amount of chlorine that is stored at the bottom of free residual chlorine, at the bottom of a settling tank, it's at the bottom of water body as free residual chlorine. Normally, the chlorine demand of water depends on nature and concentration of chlorine consuming substances present in the water, time of contact, pH of water, temperature of water, variable conditions in process of chlorination, and also chlorine demand can be determined either by graph method or mathematical method. We will discuss. What is chlorine demand? It can be defined as the differences or as difference between the amount of chlorine that is added to kill the bacteria and the amount of chlorine that is stored in the same water body as residual chlorine. It depends on time of contact, it depends on pH of water, it depends on temperature of water, it depends on the concentration of chlorine consuming substances present in that particular water body. See here, breakdown point. What is this breakdown point? See here in this graph, from 0 to C, This is a chlorine dose. Chlorine dose. And it is chlorine residual as chlorine residue is increasing. See, it is chlorine residue and it is chlorine dose as milligrams per liter. See here, we are using and we are simply adding chlorine to kill the bacteria. Am I right? After some period of time, the chlorine starts to settle at the bottom as a residual chlorine. Why we are adding chlorine? To kill the bacteria. As we are adding chlorine, after a period of time, some amount of chlorine will be stored as a residual chlorine, which is weak disinfectant. At this point, still we are adding chlorine, that will, the deposition of residual chlorine is increasing. See here. Initially, we are adding chlorine to kill the bacteria. After a period of time, the storage of residual chlorine at the bottom is increasing. 0 to C. That's what I mentioned here. On studying this graph, the residual chlorine in the beginning increases with applied chlorine dose, but after a point C, it suddenly drops. That means the residual chlorine starts oxidizing. Initially, once we are adding chlorine, there is no residual chlorine. After a period of time, slowly the chlorine is depositing at the bottom, the name of residual chlorine. After a period of time, again the concentration, or else the component of chlorine again decreasing from C to D. See here, it suddenly drops up to a point D and then again increases. The point D called as break point of chlorine, at which residual chlorine again start increasing, known as break point chlorination. What is break point? What is break point here? D. See, initially the residual chlorine deposition is increasing. After a period of time, it drops up to D, which is called as break point of chlorine. That means the residual chlorine starts oxidizing. What it is oxidizing? What is oxidizing here? Simply, it completely oxidizes the ammonia and other impurities. The color of water, which is due to organic matter, will be removed. It completely destroys all this causing bacteria and it removes odor. It prevents growth of weeds in the water. These are the advantages of break point of chlorination. Understand? See, what is break point? When the chlorine is added to water, it reacts with organic and inorganic matter and forms certain common compounds. But after a period of time, the chlorine remains as residual chlorine, which is weak disinfectant. It started storing as a residual chlorine. After a period of time, at point C, it suddenly the deposition of residual chlorine starts up to D. That means here the residual chlorine starts oxidizing. Because of the oxidization, as it is oxidizing, the ammonia and other impurities of water, because of that break point, it oxidizes completely ammonia and other impurity. That means ammonia and other impurities are taking off from the water body, and because of that, the color of water, due to the organic matter, presence of organic matter also will be removed, and it completely destroys disease causing bacteria. It removes the odor, bad odor, and also it prevents growth of weeds. After point D, again it starts increasing the residual chlorine. This is called as break point of chlorination. First adding chlorine to kill the bacteria. After addition, after a period of time, the residual chlorine is starting increasing. How long? Up to C. At what that particular points, again it drops up to D, which is called as break point. D is called as break point of chlorination. Break point of chlorination advantages are it oxidizes the impurities like ammonia and it kills entire bacteria. It reduces the odor, and it reduces the possibility of formation of weeds, growth of weeds in the water. This is what about breakdown point or a break point of chlorination. Break point of chlorination. Chlorine is demand. Why? How we can define this? Can be defined as a difference between the quantity of chlorine that is added to kill the bacteria and the quantity of chlorine that is storing as a residual chlorine, that is stored at the bottom as free residual chlorine, that is called as chlorine demand. It depends on time of contact, pH of water, temperature of water, contamination of chlorine, levels of contamination, nature and concentration of chlorine consuming substance present in the water. Hope you understood about this chlorination, superchlorination, double chlorination, plain chlorination, dechlorination, pre-chlorination, post-chlorination, chlorine demand, break point of chlorination with this graph. You must write this graph, you must draw this graph. At one side, chlorine residual as mg per liters, break point of chlorine as mg per liter. Okay, because of this break point, the advantages are mentioned here. It oxidizes ammonia and other impurities of water. The color of water, which is the organic matter, will be removed. It reduces growth of weeds. It removes the odor. It completely destroys all the disease-causing bacteria. This, we finish the topic, that is theories of disinfection. We'll discuss a new topic in the next class. If you have any doubts, please contact me, either phone, mail, or message. Thank you.